Hey guys, we are going to do our notes for section 2 in our packet today. We've already done our unit circle, but I want to make sure we've got our vocabulary and some other things for this. So let's start off with this vocabulary. Unit circle is a circle with a radius by definition of 1 unit. That's why we call it the unit circle, not units circle. And it's centered at the origin, which is the point 0, 0, and it's given by the equation x squared plus y squared equals 1. If you remember from, if you ever studied circles, we know that the general form centered of a circle at 0, 0 is x squared plus y squared, where the radius is the value at the end. For periodic, a periodic function is a function that behaves in a repetitive manner and repeats after a given period or a horizontal period. And the period is the horizontal distance before a function repeats. So basically how long it takes for the function to finally repeat. So let's talk about the unit circle. As the real number line is wrapped around the unit circle, each real number t corresponds. So think about it this way. If this is a unit, a number line, and here's the circle, if I were to take the number line and lay it on top of the circle, those values of every time I hit the circle would be t, where the distance of 1 would hit right here on the circle, like 1 radius away, and go around there. We talked about like radians. So we know the real number of t is the length of the arc on the circle intercepted by a specific angle that's given in radians. So remember, 1 radian is equivalent to the length of a radius on the circle. The real number 2 pi corresponds to the point 1, 0 on the unit circle. So if I took around the circle here, if I took 2 pi radians and went around the circle, that would go back to and hit this point, which is 1, 0 on the circle. Each real number t also corresponds to a central angle. We call it theta. And standard position, whose radian measure is t. So t is the radian measure of theta. With this interpretation of t, the arc length formula of s equals r times theta, with r always equals 1, indicates the real number t is the length of the arc intercepted by the angle theta, given in radians. All right, part 2, let's talk about the 6 trig functions. There's 6. Sine is what we've been talking about, but the abbreviation for that is, looks like the word sin, but we call it sine. Cosine, the abbreviation is cos. And tangent, the abbreviation is tan. And the cool thing about sine is that it's reciprocal. We call it cosecant, and that's abbreviation is CSC. Cosine's reciprocal is secant, and its abbreviation is SEC, and tangent's reciprocal is cotangent, and that is written as COT. So if we know T, remember, is the radians on the circle, okay? So let's say here's my circle, and there's some angle theta with T is the number of radians that it takes to get to that point. And this point on the circle, we'll call that X comma Y. So remember, we can turn this into an angle where this is X from 0 and then up Y from 0 as well. So sine in terms of radians is, remember, opposite over hypotenuse, which is going to be, in this case, 1 is our hypotenuse. So we say sine is Y over 1, which is just Y. Cosine, we know, is adjacent over hypotenuse, which is X over 1, which is just X. And tangent, we talked about today, was opposite over adjacent, which is Y divided by X, or sine over cosine, as long as X does not equal 0. And that's because we can't have X in the denominator. Same thing with cotangent. Remember that cotangent and tangent are reciprocals. So if tangent is Y over X, then cotangent is X over Y, as long as Y does not equal 0, because we can't divide by 0. Secant, remember, is the reciprocal of cosine, and the reciprocal of cosine, if cosine is X, is 1 over X, as long as X does not equal 0. And cosecant is the reciprocal of sine, which, if sine is Y, the reciprocal of that is 1 over Y, as long as Y does not equal 0. The cosecant function is reciprocal of the sine function. The cotangent function is the reciprocal of tangent. And the secant function is the reciprocal of cosine. Now, this does to complete the following tables. The chart that I gave you today, or the other day, where it looked like this, increments of 30, 45, and 60, where we know 30 is really pi over 6, pi over 4, and pi over 3 is 60. It's as easy as 1, 2, 3, 3, 2, 1, everything over 2, with roots here and here. Remember, we can use this along with all students take calculus, which tells me what's positive. And where the unit circle hits are 0, 90, 180, and 270, we'll fill all this whole chart here. Basically, using this little tiny piece of information, we can fill out this entire chart, okay? Which, if I use it properly, I'll get, if t is 0, x and y is 1, 0. Root 4 is root 2 over 2, comma, root 2 over 2. Pi over 2 is 0, comma, 1. 3 pi over 4 is negative root 2 over 2, comma, root 2 over 2. Pi is negative 1, comma, 0. 5 pi over 4 is negative root 2 over 2 and negative root 2 over 2. 3 pi over 0, or 3 pi over 2 is 1, 0, comma, negative 1. 7 pi is root 2 over 2 and negative root 2 over 2. And then you can use the rest of your unit circle to fill in that second chart if you want to. And then our last little bit of our example here. So if I wanted to find the cosine of pi over 3, I know that pi over 3 is in the first quadrant right here at pi over 3. And I know the cosine of pi over 3. If I look at my chart, here's pi over 3. So my cosine is right here at 1/2. So we're going to put that right here. And we know it's positive because it's in the first quadrant. Tangent of 3 pi over 4, remember, at 3 pi over 4 is a pi over 4 angle. 3 pi over 4 is in the second quadrant. So it looks like this. And we know tangent is sine over cosine. So the sine of 3 pi over 4 is root 2 over 2. And the cosine of 3 pi over 4 is root 2 over 2 negative. So Root 2 over 2 divided by itself is 1, and positive over negative is negative. And then cosecant of 7 pi over 6 is going to be equivalent because cosecant, we don't know on our chart, but we do know that cosecant is equal to 1 over sine. And then we can just take sine of 7 pi over 6 and find its reciprocal. So let's find sine of 7 pi over 6. Here's 7 pi over 6 is right here in the third quadrant, which I know sine of 7 pi over 6 is going to be the same as sine of a pi over 6 angle. And sine of pi over 6 is 1/2. So I know sine of pi over 6 is 1/2. In the third quadrant means it's negative. So then 1 over negative 1/2 is its reciprocal, which is negative 2. So therefore, cosecant of 7 pi over 6 is negative 2. That's all for today.